Hello, everyone. Today, let us continue discussing with the soil physics, no? And this is part of the soil science topics on the agricultural licensure exam review. Okay, before we're going to dive into this topic today, so it is strongly recommended that you must view all these previous topics, no, in soil physics, particularly on the soil physics one, which involves about soil depth, soil color, and part of the soil texture. And also, it is highly recommended that you are going to view first the soil physics 2, which talks about the soil physical properties. No? And we mentioned in there the methods by which the soil textures will be determined in the field and in laboratory. And also we mentioned about the soil textural classes and soil textural diagram. And today we'll be continuing with the soil structure. Okay, so please sit back and relax for we're about to start for the soil structure. All right, so let me share your screen. Okay, this one. Uh-huh. So let us screen. But before that, before sharing the screen, let me introduce first this particular background on my back. So actually, the background is an example of soil structure, no? Particularly the structure of Pleity soils, no? Parang look at that, parang plato ito na horizontally arranged, no? Parang horizontal plates, mayroong mga plates, different plates. So this is an example of Pleity soil structure. So we have to emphasize that in our topic. So let us go back to the screen. All right, so let me enlarge the screen now. Slideshow from current slides. Okay, balik muna tayo. Yeah, all right. So one of the physical properties of the soil is soil structure. Soil structure. Okay, of course, soil structures affects the different properties of the soils, and also eventually would affect the management of the soils, and also affect the agricultural production. Okay, soil structure. What is this as compared to soil textures that once we have discussed earlier on the previous topic in our soil physics lecture uh, 2. Okay, so structures describes the arrangement of the primary particles. Arrangement of primary particles. What are those primary particles? Primary particles are sand, silt, and clay, or the three soil separates. Again, soil structures describes the arrangement of primary soil particles into secondary particle units of aggregates. So meaning to say, so structure is just an arrangement of the particle units or aggregates. Yung sand, pwede siya magdikit doon sa silt, uh, forming into an aggregates. Pwede rin ang clay, silt, and sand, magkumpol sila sa magiging one unit or particle units or aggregates. Then that one unit will be arranged. For example, if this is a, look, imagine this hand as a single aggregates composed of clumps of aggregation of sand, silt, and clay, and the other one is the same aggregates. So sometimes the aggregates will be arranged somewhat like that, or maybe the arrangement is. But the thing is, the point is that how the aggregates of that primary particles is being arranged, be it random, be it, but the arrangement, we're talking about the arrangement. So we have some terms in here. Of course, these are just an aggregation of the primary particles. We have PID. A PID is an aggregate formed through natural process. Okay, so if we found soils on the ground or on the forest or in any agro environments, we find any arrangement of small individual particles that form naturally, that's considered as speed. No? Kanang mga na-form lang sila ng mga aggregation uh, by natural means. The other one, we have a clad. Well, it's also an aggregation. It is also aggregation. An aggregate formed through an external forces. So there must be a force that has been applied into the soil so that it would form into a clad. Actually, ang clad sa ating vernacular in Mindanao, in Bisaya, is actually itong yung tibagal or bugol o dagko nga mga bagal sa yuta, no? Kung magdaro ta, maukal ang yuta, external forces magdaro ta, external force, ang yuta mabali, maukab. Yung naukab na yuta na yon is the clad, okay? Yung pid naman is pino, no? Parang pino na mga yuta pero not form naturally. Okay? Maybe an example of this is kanang vermicast, kanang cast bitaw sa mga dagko nga earthworm nga maglingin-lingin. That example of a pid gagmay ang clad katong tibagal nga dagko. Okay? So I hope we understand each other about pid and clad. Okay? So there are some conditions that should be met for a soil to have structure. No? Paano natin masabi na ang soil ay mayroong structure? Alright. So number one, there should be an aggregation. So mayroong pagkakumpol ng mga particles or the clump of particles composed of sand, silt, and clay na aggregation. So there must be an aggregation. Okay, otherwise, kung walang aggregation, that could not be considered structured soils. So there is a definite pattern of arrangement. So maliban sa mayroong aggregation, yung mga aggregation na yon, yung mga clads na yon, yung mga clumps na yon, there must be a definite pattern of arrangement in order that the soils will be called structured soils. No? If any of the conditions, either in one or two, is not met, soil is considered to be structureless. Wala structure. So there must be an aggregation and there must be an arrangement for the soil to be considered as soils with structure. Okay? So in this particular example, structureless, a single-grain particles of soil is typically represented by sandy, for example, is considered as a structureless soil. So wala structure. Katulad nito, no? Ito ang sand in the palm and scope in the palm, no? Ang mga sand, structureless siya kasi sand, lalo na pag-uga, exists as individual particle of sands. So walang granulation dyan. Kasi walang granulation, walang aggregation because it exists as individual sand particle. Walang pagkakumpul-kumpul between sand particle or walang pagdikit ng sand and clay or dikit ng sand and silt. So individual single grain na particle, that is structureless soil. Walang structure yon. Okay? Another structureless soil condition is yung massive, no? Kanang gahi kayo ng mga yuta, no? Represented by a paddy soils. Paddy soils is basakan, no? Yung sa tawag dito sa rice paddy, yung basakan sa Bisaya, palayan na lupa sa palayan yung mga dating mayroong tubig tapos na dries up siya tapos tumigas yung lupa, that becomes a massive now. And a compacted soils is considered as structureless kasi walang granulation eh. Katulad nito, this is very hard, no granulation or no aggregation. So no aggregate has been formed in here. Okay? And of course, walang arrangement ng aggregates because walang aggregates. So this is now considered a massive structureless soils. Ito yung mga structureless single grain, typically, for example, in sand, and the massive, that is compacted or heavy soils. Okay? So, of course, for structure to occur, there must be an aggregation. Now, when we see aggregation, so there must be something, or there must be an agents for aggregation. For example, cementing agents for aggregate formation. So organic matter, okay, is one of the cementing agents. Organic matter binds particles together. Example, organic in the presence of organic matter, organic matters would able to bind between sand and clay particles or sand and silt particles because of organic matter para mag-compul sila, mag-form sila into aggregates, no? Parang mag-compul sila. Organic matter is example of the cementing agents or aggregation. Okay. Another cementing agents or aggregating agents is lime, the calcium carbonate. By the way, there are many kinds of lime. So in this particular example, we take calcium carbonate as example of our cementing agent in the lime. But there are many limes. We have calcium oxide, we have magnesium oxide, we have calcium hydroxide, we have magnesium carbonate. No? Maraming example ng lime. But this particular topic, we take calcium carbonate as examples of cementing agents. Lime encourages aggregation by bringing the together tiny particles, especially fine clay, into small clumps or granules or aggregates. Because I don't know if you could still recall, so nasabi ko doon sa mga previous topics natin that calcium is an example of aggregating or flocculating agents. Okay, and on the other side, yeah, I also mentioned about sodium as a dispersing agent para pagbungkag ang sodium. An example in our sedimentation principles of determining the texture, no? Na-mention natin doon ang sodium hexametaphosphate is an aggregate dispersing agent. So again, sodium hexametaphosphate is a dispersing agent, while calcium is aggregating agent or flocculating agent. Okay, lime is an example of cementing agents. It cements or it binds different particles so that it forms into an aggregates. All right, so that aggregates should be considered as one of the consideration for soils to be called as structured soils. All right. So the other cementing agent or aggregating agents, so that particles would bind together to form into an aggregate, is the microbial gums. Okay. So the product of microorganisms. So yung, for example, the bacterial O's, if there are bacteria in the soils, so mayroon silang byproducts na O's. That O's would facilitate the granulation and the aggregation of particles so that it forms into an aggregate. Okay, so microbial gums are viscous microbial products that encourage and stabilize crumbs or granular development. So of course, another cementing agent is the fine clay. The very fine clay bridges primary soil particles into granules. So pag mayroong clay, tawag ito, sticky kaya yung clay. So because of the clay sticky, some of the particles of the sand may be stick into the clay, or even the clay would bind between silt and the sand, resulting into a formation of granules so that the soils would have a structure. Okay, that's it. So there are the cementing agents. So parang ito yung mga agents na enhances or favors the formations of tiny peds or tiny aggregates in the soil. And structure is very important for soil. Okay, so for example, in a well-sorted sand, so take note that, so mayroon tayong individual particles, no? Okay, sa sand ito. But ito is a sand. But take note, between sand particle, so the sand particle and the sand particle, between them, there is the spaces between them. There's a space. And that space is considered as a macro pore space. Ibig sabihin na malalaking mga pore spaces and between sand particle. So dito naman sa clay particles, for example, clay particles would have micro spaces, no? So ito yung clay particles. So between them merong mga small pore spaces. Okay? So pag sa clay aggregates, Sa clay particles, between the clay particles, merong micro pore spaces between clay particles. But between clay aggregates, so this clay aggregates, this is a group of clay particles. But between clay particles, clay aggregate, this is a clay aggregate, and this one is another clay aggregate. So between them, mayroon tayong macropore species din. Again, sa between clay particles, we have micropores, individual clay, no? Individual clay particles dikit to another individual clay particles. Between them, there is a micropores. But sa clay aggregates, sa group of clay, so between clay aggregates, between a group of clays, mayroon tayong macropores. Okay? Alright, the macropore species in clay soils formed due to aggregations allows free movement of air. Again, so the macropore species in clay, so ito. So this one, a macropore species in clay aggregates. Okay, ito yung mga macropores. This one are macropores. Ito mga spaces na to. Again, macropore species in clay soils formed due to aggregations allows free movement of air and water. So in this portion, there's an exchange of water and air in this portion. Hence, well aggregated clay soils have good aeration and drainage. Now, if our soils is clayey, so we have to make sure that there must be an clay aggregation. Otherwise, kung walang clay aggregations, if the clay exists as individual clay particles, so we would have a problem of aeration. Katulad ditong micropores, no? Katulad dito, individual clay particles, walang aggregation, we have a micropores. So the problem of air movement and water movement in that. Let's proceed now. I hope you understand this now. Let's proceed. So there are bases for classification of soil structure. No, we have to classify soil structure based on shapes of aggregates. No, shape ng mga pagkumpul-kumpul. So because of the shapes, we have the types of soil structure. Then we also have to classify soil structure based on size of aggregates na may gagmay nga mga aggregates na pwedang ko, no? That's why we have the classes of soil structure. And also, we have to classify the soil structures based on durability of aggregates because there are some aggregates, there are some clumps that would easily be broken, and there are some clumps that is relatively stable and strong. No? Ganun. So because of durability of aggregates, so we have to classify soil structure based on grades of soil structure. Pag grade of soil structure, this is based on durability, no? Madaling mabungkag or dugay mabungkag grades. Okay, let us proceed. So first, types of soil structure based on shape, no? Based on shape, we have types of soil structure. The first one is we have the spheroidal. Okay, spheroidal soil structure, or spheroidal could be a granular or could be a crumb. Okay, actually the spheroidal, granular, and crumb soil structure is the best soil structure in the upland. It's good for the soils and good for agriculture. Itong spheroidal, granular, and crumb. Katulad ng, for example, kung magtatanim tayo ng mais, no? Lagay natin yung seeds doon sa field. So mas maganda yung structure ng soils natin, natanamin natin ng mais, dapat ang soil structure is spheroidal, granular, or crumb because those are uh, the best soil structure in the upland. Ibang istorya na rin yun pag doon sa lowland kasi ang lowland is walang structure. Structureless yung lowland, no? Yung basakan. Alright. Granular is is porous, meaning to say in granular or spheroidal particles, the water and air can move in that particular soils. And also pag crumb, this is very porous. The water and air could even move easily compared to granular. Okay, individual particles, sand, silt, and clay group together in a small, nearly spherical grain. So under the spheroidal, so itong individual particles of sand, silt, and clay, dikit-dikit sila, forming into nearly spherical grains. Itong spheroidal, granular, grabe, parang ano sila, parang medyo may pagka-bilog, no? So katulad nito, okay, I don't know if we can superimpose this one. This one is parang bilog, bilog ito na particle, that is spheroidal. This one is medyo bilog na konti, not perfectly na bilog, but ganun ang ibig sabihin doon, no? So medyo maliliit na mga may pagka-bilog-bilog. Okay? That is the spheroidal, granular, or crumb. So water in a spheroidal circulates very easily, through such soils, commonly found in the A horizon o dun sa surface soils of the arable soil or on the plow layer. So arable or EP, itawag na EP horizon. EP horizon sa ating that is the arable soil. All right. So let's proceed. The other one is the Pleity structure based on shape. Ito yung background, ito yung background ko dito sa look at me, look at my background. So ito yung background, no? Kita niyo sa inyong background ko po. So pinili ko kanina. Anyway. Okay. So let's proceed. So another example of structure based on shape, we have the Pleity. So Pleity, para siyang or plate-like, parang plato nag-i-arrange na horizontally. Katulad dito, parang na-plates, no? May mga plates arranged horizontally. So mayroon mga plates sa ilalim. Dito, yeah. Yeah, look at that. Parang may plato na ina-arrange horizontally. So look at that. This is platy structures commonly found in the forest soils, no? Yung mga undisturbed forested areas in part of the A horizon and in a clay pan. So mayroon din ito sa A horizon, mayroon din ito sa clay pans. Ibig sabihin yung mga cementations ng clay sa ilalim, no, ng lupa. Ganun. So we have plate-likes. Then another, we have the prism-like. So the prism-like is ito, no, parang column. Prismatic, may mga column ng lupa. Okay, I don't know if we can, sorry. So mga column ng lupa. The other one, we have the columnar. So columnar, the same, parang may column ng lupa, pero merong sodium cap, no? Itong puti-puti sa taas, may mga sodium cap sa taas because of evaporation. Because usually the soils structure, columnar soil structure, observed in arid regions in Saudi Arabia. So prism-like, prismatic, and columnar. So look at that. So soil particles have formed into vertical columns. So tingnan nyo, mayroong mga vertical column din, no? May mga ganun vertical column. Katulad din, may mga column na vertical. Katulad din, vertical column, another vertical column. So pataas ba, no? Vertical column. So some particles have formed into vertical columns or pillars separated by, parang mga pillars na mga, parang mga haligi, no? Pillars separated by miniature but definite vertical cracks. So mayroong mga cracks vertical. Katulad ito, may mga cracks vertical. Alright. So, sorry. Okay. So water circulates with greater difficulty. So water's circulate difficulty and drainage is poor. Particularly dito sa ito, water cannot move freely, Commonly found in B horizon. This one is in B horizon, no? Nasa medyo sa subsurface area ito. So commonly found in the B horizon subsoils in arid to semi-arid region. So arid region, yung mga mamainit na lugar, malalakas yung evaporation kaya mayroong sodium cap. Kasi pag evaporate ng water, yung sodium maiwan doon sa lupa because sodium is hindi siya pwede magiging gas, ayaw niyang sumama doon sa atmosphere during evaporation. Okay? So that is prismatic and columnar. So another structure we have is the block-like, or mga bloke, no? Mga bloke na guys. Block-like, pwede ito angular, pwede subangular. So katulad dito, may mga bloke-bloke, di ba? Ito isang bloke. Okay? May mga bloke-bloke ito. So there's a block of black shapes of mga blocks. Look at that. So may mga blocks. Okay, soil particles cling together in a nearly square. So pwede siya maging square or angular. May mga angle-angle. Katulad dito, may mga angle, no? Angle, merong angle. Tak, merong angle sa bagit. Ito, merong angle. So soil particles cling together in nearly square or angular blocks having more or less sharp edges. So mga matatalim itong mga edges nito, no? Sharp edges. Ganyan. Relatively large blocks indicate that the soil resists penetration and movement of water. Okay, commonly found in the B horizon where clay has accumulated, usually in the humid regions. No? All right. So classes of soil structure. So what are the classes of soil structure? We have very fine structure, fine, medium, coarse, and very coarse. That's that. The Pleity, we also have a Pleity shape of soil structure. There's a very fine, but the very fine Pleity structure is less than 1 mm. So on and so forth. Ang prismatic, less than 10 mm. So just be familiarized with that. So the graded of soil structure is based on, let's go back. So when we say the grade of soil structure, so we're talking about how strong is the structure. When we talk about grades of soil structure, how strong is the soil structure when subjected to forces. Okay, example, grades of soil structure, we have structureless. Of course, pag structureless soils, no aggregation or no orderly arrangement of the aggregates in a structureless. Example, single grain, individual grain, sand, weak soil structure based on durability, poor form. So yung forma is pangit, no? Dali lang non-durable, dahil ra kayo mabungkag. Poorly formed, non-durable. Indistinct peds, no? Wala siyang kumpul-kumpul ng mga granulars. And parang walang peds. Kung mayroon mang peds, very weak, no? Indistinct peds, breaking into mixtures of few entire and many broken peds and much unaggregated materials. So parang wala aggregation, walang pagkakumpul-kumpul. So another, we have the moderate durability, moderate soil structure. So the moderate soil structures will form, maganda yung forma niya, meron siyang structure. Then indistinct in undisturbed soils that breaks into many entire and some broken but little unaggregated materials. So those are strong grades of soil structure based on durability. Okay, strong soil structure, durable, distinct peds. So naiklaro kay mga aggregates, nagagmay nga aggregates, weakly attached to each other. For example, this one is considered as an aggregate, another aggregates, they attach to each other, weakly attach each other that breaks almost completely into entire peds. Pag mabuak siya, so it forms a single peds. Now, that is a very strong grades of soil structure. How will you describe soil structure now? So we have to describe soil structure first based on grade, class, and type. Ano natin yung grade? Ano yun? Balik tayo. Sa grade, we have structureless, weak, moderate, and strong. Then in terms of classes, we have fine, very fine. In terms of type, we have the blocky, columnar, prismatic, and the Pleity. So those are just, okay, how will you describe now? We have to describe based on grade, based on classes, which is the size of the grades, and the size of the particles. Then grades is the durability. Then types of soil structures, be it the blocky, spheroidal, prismatic, columnar. Example, a soil is weak. This is how we describe soil structure. A soil is weak which is based on durability, which is the grade. No? Look at the color, the same ang color nila, because this is the grade. Again, soil with a weak, then medium, based on size, no, of the particles, size of aggregates. A soil with weak grade or class, the medium, and angular soil structure, angular blocky structure. So angular, yeah, blocky ang yang structure. It's how we describe soil structure. So for example, aggregate size is 8 mm, and that is uh, okay. The grade is 3, and granular structure. For example, aggregate size is 8 mm, then grade is 3, granular structure, then a soil with strong, coarse, granular structure. A soil with strong. This is now the grade of soil structure. Coarse. This is now the classes of soil structure. And granular structure is the type of soil structure. This is how we describe soil structure based on grade, based on class, and based on type of soil structure. Take note that tatlo. No? All right. What is the importance of soil structure to plants? No? Soil structure will determine the distribution of pore space. Ibig sabihin, uh, mga pore spaces, we're talking about the portion or the space in the particular soils, the space between aggregates. No? Again, soil structures will determine the distribution of pore spaces in the soil, which in turn will influence air and water movement within the soil. Yun, no? Ang soil structures affects the distribution of pore spaces. And eventually, that pore spaces, amount of pore spaces, will determine the amount of air and water movement in that particular soil. So again, dapat ganun ha. So ang soil structure, ang yung effect on the distribution of pore space and effect ng air and movement of water, which eventually maka-epekto din sa crop production. So that's how the soil structure should affect farming and agriculture as a whole. Ano no, affects siya sa movement of water and air, which affect eventually plant growth and production. Okay, soil structure should affect the bacterial activities, no? Bakit mag-apekto ang soil structure sa bacterial activities? Because bacteria is a living organism. Some of them requires oxygen, although there are some bacteria that does not require oxygen, and other bacteria requires air. Okay, because of soil structures affects aeration, and eventually it affects bacterial activities such as decomposition, no? And fermentation, ganun, and oxidation. Yan, that's how the structure affect bacteria. Again, soil structures would affect the bacterial activities such as nitrification, an example of bacterial activities. Ibig sabihin ng nitrification, conversion of ammonium from fertilizer, ammonium sulfate, conversion of ammonium in the soil into nitrite and eventually into nitrate or NO3. So in its spore, this is in its spore, ammonium converted into, i-short na lang ako, NO3, although mayroon pang process dyan. But conversion of ammonium to NO3, mayroong mga organisms na involved dyan before ma-convert yan. But you have to deal with that clearly later on. Okay, soil structures would affect the bacterial activities such as nitrification and mineralization. Ibig sabihin ng mineralization, pag mayroon tayong nutrients na hindi available to plants, we have to mineralize that so that it will dissolve cations and ions that will be absorbed by the plant. So this is the importance of soil structure. So I hope you gain understanding about soil structure. Again, soil structure refers to the arrangements of individual aggregates, and there are some basis for determining if the soil has structure or not. So for the soils to have a structure, it must have an aggregation, it must have an arrangement, And we talk about different cementing agents or aggregating agents. We have talk about the limestone or the lime. We have organic matter, clay, and so on and so forth. We also classify soil structure based on shape. We have the blocky, the angular, the columnar, the pleity. There's the prismatic based on shape. We also discuss based on size. No, we have the fine, very fine, and medium, ganun. And we also discuss based on durability. That is, we have grade. So there are strong grade, weak grade, moderate grade soil structure. That's how we describe soil structure. And we also uh, discuss about the importance of soil structure to plants in terms of distribution of pore space, air and water movement, and bacterial activities. So that's it for our soil structure. I hope you gain understanding for that, no? And thank you for listening. Thank you for listening. Then next time for our discussion, we have to discuss about soil consistency. So please don't forget to attend our coming discussion. So thank you for listening, and I hope you have a good day. You have learnings that have you gained today. Okay. So next meeting, don't feel to attend with us. So please invite your classmates for this lecture. So thank you so much until next meeting.